Hi everyone, welcome to the Project 3 presentation. So for this project, we were doing natural language processing on finding a name classifier, a first name classifier. So we took the data set from the Natural Language Toolkit package called names, and we brought that in and we did some analysis on it. So that's what that's what we're going to talk about today. So we brought in the male and female text. We found that there's about almost twice as many female names as male names. We looked at the distributions of them to see how many male and female names started with different letters of the alphabet, as well as how many ended with different letters of the alphabet. And so these are some of the features that we're going to be using as we build our classifier. So we did some cleaning. We did some after we did the exploration, we shuffled them, and then we split them up into a development set and a dev test set that we can use to improve our model, and then the actual testing data set. So so we found that we have 7,500 unique names. A number of them are listed twice, though, as both male and female names. Also, a number of them are duplicates, so we're going to remove those as well. So we found a pretty good long list of duplicates. Whoop. And we also found some that were in both male and female data sets. So after removing the duplicates and removing the ones that appear twice, we are down to a list of 7,200 total unique names. So from there, we split them up into our dev set and our training set. So we have 6,200 in our training set, 500 in our dev test set, and 500 in our final test set. So with the final test, we look at the distribution of names. We still have about twice as many female names as male. So sometimes what you would do is you would make those two equal, but it's only really necessary when you have maybe like a 1 to 10 ratio. So if maybe there was only 400 male names, then we would reduce the number of female names in our training set, so we wouldn't have so many outliers. But in this case, we didn't have to. So we used our naive Bayes classification. So we ended up with, I believe, 7 different classifiers. So let's go through what a couple of those were. But before we get to that, for accuracy, what we're looking at is precision and recall. So we're looking at false positives and false negatives. And this should be familiar from earlier classes. So first we defined a number of measures that we can use for our model, or to train our model. So the first classifier that we're using is first letter of your first name. So when testing it, we found that it has about 0.6% or 66% accuracy. For the false negatives for males, we say that that's pretty low. False negatives for females is pretty high, and false negatives for females is actually pretty low. And we see it's the same in the dev test set. So not too much difference there. And we find, which is good. We want to make sure that there's not too much difference between the dev training set and the dev test set. And we find that these are the highest informative features for first letters of the first names. We're going to do the same thing for last letters as well. Last letters we have a little bit higher, actually quite a bit higher, a very little, not nearly as low of false negatives for males compared to females with using the last letter. So let's take a look. Last letter is some really informative features, which leads to a better prediction overall. So so these are the single letters that we're looking at. Now we're getting into the bigrams. The bigrams are cool is we're taking the last two letters of each name, and still we're still getting some even better accuracy measures. Um, Still see a little bit lower false negatives for males than females. False positives are pretty okay. Now we're seeing some really good informative measures for the bigrams. Um, Now we're going to start looking at some trigrams and fourgrams as well. So these are the last three letters, last four letters, but we're also doing the first three letters and first four letters as well. So if we look here for Mademoiselle, we see that the first one, the last letter is an E, the last two letters LE, last three is LLE, first four, or in first three and first four are there as well. And so on this training, we see we have a really good accuracy with these trigrams and fourgrams. So let's take a look at some of the measures that are high. A lot of the ones that are best performing are still one letter and bigrams. So we're definitely going to be using a lot of those in our final model. Next, we're going to look at the syllable count. Also the boba and kiki letters as well. So syllable count. This is the formula that we're using for that. And the boba letters are listed here. The boba and the kiki letters are here. So combining the boba letters, the kiki letters, and the syllable count, it really helps. If reading from these links, it really helps with international names. So it's going to be a better predictor for a wider variety of names. Compared to maybe the limited number of names that we have in our training set. So these features are going to help us with, be able to classify more and more names. So we see here, so based on the boba and the kiki letters and the syllable count, there's 5 boba letters in Mademoiselle, 4 kiki letters. There's 4 syllables, Mademoiselle. Mademoiselle. Oh boy, that's okay. I'm not going to erase that. I already did enough takes. So looking at so now we're going to look at, I believe, all of these, right? So we're putting all of these together into our final classifier, and let's see what we get. So we're getting so we have some pretty high accuracy with the dev set and the test set. Our false positives and false negatives are really good for the training set. They're still really good for the dev test set as well. And let's take a look. So we don't see any of the syllables or the bobi or the kiki features finding their way into the highest informative features, but we're still looking pretty good. So let's do some error analysis and figure out what exactly might have been some issues. So looking through, here is the list of the incorrectly classified names. So out of the 500 names, only 47 of them were calculated incorrectly, and that's fantastic. That's less than 10%. So we're going to do a confusion matrix, which is down here. So here's our the final accuracy for our dev test set for the false positive, correctly identified female names and male names, and the false positives and false negatives for each, or excuse me, the incorrectly identified names in each. And here's our final tally for the precision and recall for the false positives and the false negatives, which looks pretty good. Our F measures look good as well. So here are the errors that we're having on our final test set. Um, they're listed there. And this is the accuracy on our final test set. This looks pretty good. It's looking pretty consistent with our dev test set. How does the performance on the test set compare to the performance of the dev's test set? It's pretty similar. So let's take a look at. Oh, I think that was it above. So how does this performance compare? What do you expect? So the accuracy went down from 94.5% to 89%, which is not too bad of a drop off and about what we would expect. We ran the feature generate the feature function that we generated 100 times, and then every name was shuffled at the end. So it's not exact, but it's pretty close, which confirms our expectations that this is a good model. And so now we're going to take this model and we're going to test it on something that's much bigger. So on data.world, we found a data set with almost 33,000 different names. And so for our test set, we've had on our 500 names, we had 89% accuracy. So let's take a look at what we get when we do it on 33,000 names. And it only drops to 86%. So we're still getting 86% accuracy on our tests on these new names that were not in our initial data set, which doesn't differ a whole lot from our test set. I'm sure there's a much wider variety of names in there from around the world. So this is really fantastic that it was able to accurately predict so many more names that we weren't initially working with. So overall, the class did pretty fantastic in putting all of this together. I know I learned a lot from everybody else. With the different ways that people do different functions and the way that people are coming up with different features. So I love working with everyone, and I hope you guys enjoyed the presentation. Have a great day. Bye bye.